Hello everyone. Today I would like to show you my latest project. No, don't worry, it's not another radio receiver. This one is the very opposite of a radio receiver. It is a low-power radio transmitter, one that you may want to build for yourself. These low-power transmitters are often called AM broadcasters. They are used to transmit a vintage radio program from recording to an antique radio receiver. The Shadow is my example. This is a nostalgic way to show off your old radios. AM broadcasters have been commercially available since Philco offered one in 1930. Later, Lafayette and Allied Radio offered 3-tube broadcasters. You can find AM broadcasters on eBay. This project is called a low-power AM broadcast band transmitter. It was posted online and designed by John DiMaggio, K5HTZ, his call letters. John has provided us with an excellent, high-resolution printable circuit diagram with all the part values included. I just had to build it. Here's a quick look at the schematic. This schematic is well laid out and very easy to read, but unfortunately it does have one mistake. It is in the power supply. Do you see it? This is my working schematic. I use a marker to color in each part as I mount it, and then each wire as I connect it. This way, when I leave the project and return to it later, I know exactly where I am. When everything is colored in, I am ready to power up. Please note that none of the power supply is colored in, but more about that later. As usual, I have used breadboard technique. Everything is mounted on a 1/2-inch plywood measuring 8 by 10 inches. Here's what it looks like. This is a 6V6 oscillator, which is crystal controlled. John picked 1000 kilocycles to avoid any commercial broadcasting. Here is a 6V6 green grid modulator, and here is a 6SN7 dual triode audio amplifier. Although John gives instructions for winding your own output coil on a 5-pin plug-in coil form, you can use any antenna coil covering 540 to 1600 kilocycles. Here I have used a new old stock Miller antenna coil. You may have noticed that something is conspicuously missing, the power supply transformer. Well, I built a lot of projects requiring a power supply transformer. They are expensive to buy, and salvaged ones are hard to find. So I use an external power supply. And here it is. This is my high voltage regulated power supply, Heathkit IP17. And yes, I built it myself. It provides 6 or 12 volts for the filaments, and a variable regulated B+ and C voltages. 2 meters indicate power draw and voltage. This is a very handy device. Unfortunately, my broadcaster did not work immediately when I first powered it up. I connected the output to my scope, and I saw a blurry, unrecognizable pattern I couldn't identify. It sure wasn't the carrier wave I expected to see. A friend told me that what I was seeing was a mix of a very high frequency with a low frequency. The high frequency was to be expected, but where did the low frequency come from? The only low frequency in this transmitter was a 60-cycle filament voltage. I had neglected to keep the filament leads away from the signal wiring. The cure was to put the filament wires underneath the breadboard and twist each pair of wires tightly. Problem solved. When I found out how well this transmitter works, I not only decided to feature it in a video, but I decided to dress it up a bit with a cover made from a piece of ornamental sheet metal from Home Depot. One more thing to keep in mind. John points out that this transmitter may exceed the FCC power limit for unlicensed broadcasting. A short wire antenna is all you should use. This project is for the intermediate to advanced hobbyist. Take a look at the schematic online and decide if you want to give it a try. Good luck and happy building.